Okay, on number 1, you are adding like terms. So when you add like terms, you have to find variables that have the same exact letters with the same exact exponents. So 7a squared minus 10a squared is like terms. So I can do 7 minus 10 and get negative 3. And you keep the a squared. There was nothing like the 9a, so that stays exactly the same. So when you add like terms, exponents do not change. For number 2, 13x squared and a negative 6x squared are like terms. So I can do 13 minus 6 and get 7, and I keep the x squared. And then I can't combine that with 9y squared because x and y are not the same variables. For number 7, there's an addition sign between these two sets of parentheses, so the parentheses don't even matter. So I'm just going to ignore the parentheses. But 5n cubed and 18n cubed are like terms, and 6 and 9 are like terms. So I can add 5n cubed and 18n cubed and get 23n cubed. There was nothing to add to the 3n, so I'm just going to put him in there. But I can add the 6 and the 9 and get 15. For number 9, same thing. I have an addition sign between my two sets of parentheses, so these parentheses do not matter, so I'm going to ignore the parentheses. So I don't have anything that's like 9x squared, so I'm going to keep it. Notice I'm always starting with the highest exponent first. But negative 3x and 2x are like terms, and 12 and negative 18 are like terms. So negative 3x plus 2x, different signs subtract. So 3 minus 2 is 1. Keep the sign on the 3. So that'd be a negative x. And then positive 12 minus 18, different signs subtract. Keep the sign on the 18. So that'd be a negative 6. Number 11. Now this is a minus sign. That means everything in the second set of parentheses switches its sign. So it becomes plus the opposite. So I'm really doing a 6c to the 4th plus a negative 2c to the 4th. So now my signs are different, so I have to subtract. I get 4, and you keep the c to the 4th, because when you add, exponents do not change. There was nothing like the 8c and nothing like the 6, so I just tack those on the end. Number 13, there's another minus sign. So I'm going to rewrite this problem. It gets rewritten as 2r plus 5, and then it's like distributing a negative 1. So I'm going to do negative 1 times 5r and get negative 5r. I'm going to do negative 1 times negative 6 and get a positive 6. So then my 2r and my negative 5r are like terms, my positive 5 and my positive 6 are like terms. So 2r and negative 5r, different signs subtract, so that's 3r. Keep the sign that was on the 5, so it's negative 3r. And then 5 plus 6 is 11. Okay, for the next section, number 2, I have to simplify that. Well, I know when I divide like bases, I keep the base and I can subtract the exponents. So 2 to the 2nd divided by 2 to the 9th, I can just keep the 2 and subtract 2 and 9. For 3 to the 4th divided by 3 to the 5th, I keep the 3 and I subtract 4 minus 5. And there's nothing I can do with 4 to the 4th. So when I simplify this, I get 2 to the negative 7th, 3 to the negative 1st, and 4 to the 4th. But anytime you have negative exponents, they get flipped to the bottom. So the only one that's not negative is 4 to the 4th, so it stays in the top. But 2 to the 7th goes to the bottom, and 3 to the 1st goes to the bottom. So 4 to the 4th, if I did 4 times 4 times 4 times 4, 4 times 4 is 16, another 4 times 4 is 16. 16 times 16 is 256. 2 to the 7th, well, I know 2 to the 6th is 64. So then 2 to the 7th, I'd have to multiply another 2, so that'd be 128. So that's 128 times 3. I know that 128 can cancel into 256 twice. So then when it finally simplifies, it ends up being 2/3.